So, as I said, a relation is an association between two quantities. So it's just really a relation. A relation is a relation. It shows relationships. One is the independent variable, and the other is the dependent variable. Now, you do this in science all the time. Right? When you're measuring how long it takes to melt water, or ice, sorry, the time is the independent, and the dependent would be the temperature of the ice. Okay, you can measure that to the boiling point. So this is your independent variable. Independent, go ahead. That's your x value. And then you have your dependent variable, and that is your y values. Okay. And what we can do is we can do a depends on sentence. So we can say blank depends on blank. And that depends on sentence helps us figure out which one's the dependent and which one's the independent. So you can just use that sentence and fill it out. Please write that down. It's really, really important. Okay. So we'll be covering that again a little bit later, but this is a really good intro to what dependent and independent mean. So for example, the tickets and the profit. The profit depends on the number of tickets sold. Okay? The number of tickets doesn't depend on the profit. So you have to make the sentence make sense. Now, relations can be expressed several ways. It can be in words, like a sentence. Okay? So the color of different apples are, okay, or what are the colors of different apples? So you can also express it as an equation. Harder to do for the example I gave, but we can say a number increased by 3. That would be y equals x plus 3. You can also write as ordered pairs. So that's using your brackets and a comma to separate ideas. You can even use words in there, right? For example, you can do bracket January, comma 31. What did I just express? January has 31 days. Okay. You can also put that in table of values. So that's the fourth way to express a relation. And last but not least, as a graph. So most likely it's going to be points. It can be a line, or it can even be a bar graph. So here we have all 5 different ways. Number 1, in words, we can say the dependent variable is the square of the independent variable. So we take those words and let's make a table. If x is 3, what would y become? Well, x is the independent and y is the dependent. So the dependent is the square of the independent. So y then would be 3 squared, which would be 9. Okay, so y is the square of x. What if x was 2? What would y become? 4. If x is 1, what would y become? 1. What if x is 0? Be 0. If x is negative 1, negative 1 in brackets squared, what would that be? Positive 1. Okay, so this is kind of a special graph. It's kind of weird here. In negative 2, you would have what? Positive 4, because it would be negative 2 squared. Negative 2 times negative 2. So don't forget about your exponent laws. Okay, if in brackets, it's negative 2 times negative 2. And what would negative 3 squared be? Positive 9. Okay. So we can then take that. Now usually, right, you should at least do 2 to negative 2. Okay. This is usually what you pick. Right. Pick these for x. So then you can guess. Not guess, but then you can figure out what y is. So those are the typical range, typical domain. Now, I want you to write these all as ordered pairs. Okay, write them as ordered pairs. So for example, 3, 9 would be 3, 9. and that's why we have x first. 2, 4 would be 2, 4. 1 and 1, 0 and 0. Make sure you have brackets and commas. That's extremely important. -1, +1. -2, +4. And -3, +9. Okay. So this is the second way. This is the third way to write the same data. Now I want you to graph it. Here's your x-axis. There's your y-axis. So there's solid lines in your photocopy. I want you to graph it, starting at 0, 0, your origin. Plot the points, please. So 3, 9 will be off our grid. I mean, it's going to be like way up there. Okay. So then we have -1 and 1, -2 and 2, and then we have -3 and 9 way up there. So you can kind of estimate where that would be. So we have a mirror image, right? Left side and right side of the y-axis are identical. What kind of shape are you going to make here? It's going to be a U shape. You go down to 0 and then all the way up. Whoops. Down to 0 and then all the way up. Okay. Oops. I should be on that point. Let me fix that. Okay, so this is called a parabola. You're going to see a lot more of those in pre-calc 11. Okay, don't really need to know the name, but the ordered pairs tell you and show you it's not a straight line. So it's not linear, it's a U shape. We call that a parabola. Now, what would the equation be? Look at the sentence again, see if you can make up an equation. So we're going to start with y equals square of independent. So here's x. What did we do to x? Squared it. There's your equation. Okay, y equals x squared. So we have 5 different ways of expressing the relation. And you're going to be doing that in your homework. Sometimes you'll be asked to write ordered pairs. Sometimes you'll be asked to graph. And it'll be a straight line. Sometimes not. Sometimes you'll be asked to make a table. Sometimes an equation. Sometimes it'll be a sentence. Okay? So here we want to talk about domain and range and define them. Domain is your x values. Okay. That is your inputs. Your range would be your y values. Those would be your possible outputs. Okay. Now keep in mind your domain is kind of your left to right, and your range is your up and down. Okay. So if you're looking at this graph, there's nothing stopping it. It's still going to the left. So there's nothing stopping it from going to the left, and it's still going to the right. So nothing is stopping it from going in this direction. So what we say round bracket, negative infinity is where it can go to, and it can also go to positive infinity. Nothing stopping it. Okay. Now we're going to talk more about domain and range in a while, but I just want to show you there's nothing stopping it from going left or right. For your y values, what's the bottom value that it touches? It doesn't go any further past 0. So this should be a square bracket because we actually reach 0. But is anything stopping it from going up? No. So it's going to go to positive infinity. And we use a rounded bracket because we never reach infinity. As soon as you think you're there, just add one more, right? And then, add one more, and then one more. So we use rounded brackets because we actually never reach infinity. We're going to talk more about that later and give more detailed notes, but I just want to throw it out there for you. Okay? So in the red writing, don't really need to know. Now for this one stops and goes up. So we actually do have a bottom value here. All right. What we're going to look now is we're going to go from a relation, which we have here, to just looking at functions. Functions are special relations. Okay. So what we need to know is that all functions are relations, right? They're special ones, but not all relations are functions. So we're going to look at the details. What makes a function then, right? Because some things aren't. So what's so special about this exclusive club? One thing is that there's one output for each input. So that's like saying one y value for each x value. And right after I say that, I want to let you know that different x values can have the same y. And we're going to see that in a second. Okay, so it can work one way, but not the other. And the other thing is it passes the vertical line test. So if I give you a graph, you're going to use a vertical line. And sometimes we call that the pencil test. Okay? Because a pencil straight up and down is vertical. All right, we'll talk about that in a second. So let's have a look at this one output for each input. If you're looking down here, we have a 0, but there's no other zeros with a different number. We have a 1, input of 1, but there's no other 1s in the input. Just keep in mind, this is your input, and this is your output. Okay? It's because this is your x and your y. So when I'm talking input, I'm talking about the very first number. So we have an input of 2, there's no other outputs except for 3. Input of 3, no other outputs. So I can look at those points and I can say this is a function, fxn. That's the shortcut for function. Okay. And the reason why is there's one output for each input. If you don't have a reason, you're not getting a mark. Now what we can make is an arrow diagram. So we need to know what arrow diagrams look like. This would be your inputs, which are your x values. And this will be your output, which are your y values. Now, as you're doing your homework, we can also use words here. So your inputs could be the fruit names, like apple, banana, orange. And your output would be colors, like yellow, green, red, and orange. Okay. So words are okay. Input of 0, 1, 2, and 3. And the output would be 1, 2, 3, and 4. And for us, this is a real simplistic one. One thing to note is there is no splitting of the arrows. Okay? So 0 doesn't have 2, 1 doesn't have 2, 2 doesn't have 2, 3 doesn't have 3. What would be the equation for this? So we have y equals x, but if we start with 0, how do we get 1? If we start with 1, how do we get 2? If we start with 2, how do we get 3? And you just add 1 each time. Okay? And so that would be your equation. Now sometimes they get harder, and we saw in grade 9, there's a lot harder ones, right? Like you get fractions and stuff. We don't really focus on that too much anymore. Now let's look at this next arrow diagram. One thing that you should notice, 6, right? There's 2 outputs. For 6. So here we'll say it's not a function because the input 6 has 2 outputs. Okay. Now in your arrow diagram it's going to look different. We have 4, we have 6, and 8. You don't need to write numbers twice. Okay, just write it once. And then the output would be 2 and 3. Again, you don't need to write 2 more than one time. Okay, don't need to double represent. So for the arrows, 4 goes to the number 2. 6 also goes to the number 2. That's okay. That's still a function. But now watch this. Now I split 6. 6 has 2 arrows going away from it. That's the problem. Okay? So what we have here is we have splitting. Right? 6 can split into 2 different directions. Now 8 can go to the number 2. That's no problem. The problem is that 6 has 2 arrows. Okay? Notice that we do not repeat elements. Okay, so we do not go 2, 2, 2, 3. Okay, no. What you do instead is you go like that. Okay, you don't write numbers more than once. You just use the arrows. Any questions? The other thing I didn't do over here is I didn't go 4, 6, 6, 8. All right? I don't do that. All right? I also just write it as 4, 6, 8. All right? So a little bit of thinking there. Not a lot of numbers, not a lot of calculations, I mean, but you got to represent it properly. Okay, have a look at 3 and 4. Tell me if it's a function or not a function. And tell me why. Go. Okay, number 3, what do you guys think? Function or not? Yeah, it's a function. Because, B/C is because there's one output for each input. Okay. This is all right. This is okay. There's nothing wrong with that, right? 4 and 6 can have the same output. That's still a function. Okay. Well, number 4, what do you guys think? Function or not? It's still a function. Okay, and that's because there's one output for each input. Okay. When you look at this, there is no splitting. Right? No splitting. So you don't have the double arrows. You guys okay with this? Thumbs up down the middle. Okay. Now again, your textbook questions are going to rise above a bit, so if you're kind of stuck, come ask for help. Vertical line test, a special test to see if a graph represents a function. Okay. A vertical line only touches the graphed line once. So that's how you know that it's a function. Okay. So if it's a function, you're only going to have a vertical line touched once. So this reminding you is you can use your pencil. We sometimes call it the pencil test. So I have a vertical line. It's going to be the color blue. And if you look at this vertical line, it touches the graph right here once. We're not talking about the axes. We're just talking about the graph. Now as I move this line down from left to right, the vertical line is only touched once. Okay? I can go this direction, okay, but it only touches once. Whereas here, it's touching at the top, but now it's also touching at the bottom. So that's the difference. Okay? If I take this line and move it over, back here, it's only touching once. Okay? So here, I can get rid of this touch. It's only once. So this one is a function. Fxn. But then I look over here, I'll draw the example. Okay. Here we have double touching. So it's not a function. Okay. Next one, what do you guys think? Use your pencil. Right? I have a vertical line, but you can use your pencil, put it down over top. How many places does it touch this line? Once. So this is a function. It passes the vertical line test. What about this ellipse? How many times is it being touched? Exactly. Once at the top, once at the bottom. So it's not a function. Pretty easy to do. Now we have an exception. Okay, well, not an exception. You have to be careful here. Remember, if we have x is greater than 2, how would you graph that? You put 2 in the middle, number higher, number lower, and it should be in that order. And this would represent, you would use an open circle. Okay? And that's because the point is not included. And then we would shade in this direction. Okay, so now we have the exact same thing. This here represents an open circle, so the point is not included. But then you could graph something like x is less than or equal to -2. And so if you graph that, here's -2. What's the number higher? -1. Good. That's a tricky one. -3 is lower. Would I use an open or closed circle? Well, I'd use a closed circle. Okay. And the closed circle means that the point is included. So you need to remember what the difference is between an open and closed circle on a graph. Here the value -2 is included, and I'd shade to my left because x is less than it. Okay. And we're going to be using those inequalities, less than, greater than signs in a couple classes with domain and range. So here your point is included. So what that means for the vertical line test, let's do a vertical line at one of these situations. This means that it is touching at that point, but down below it means that it is not touching. Okay, because of the open circle. Okay. So you have to be super careful with that. So this one is a function because it passes the vertical line test. All right. So a little bit of review on how to graph inequalities, open, closed circles, what that means with our vertical lines. Okay. This is like an instantaneous jump up. Here's a function versus not a function. What it looks like with an arrow diagram, function versus not a function. So looking for number 2. Now you can just look at the values of the points and see if there's doubling. For example, I'm looking here and like, oh, there's 2 6s. That means it's not a function. All right. One output for each input and different ways of writing it. So that's what we're looking at today. What's a relation? What's a function?